While you sit here, the planet beneath you is moving, not just around the sun, but as part of a galaxy that is physically sliding across the universe at over 1.3 million miles per hour. We know our exact speed because of the cosmic microwave background. This is the oldest light in the universe, a fossilized glow from the Big Bang that acts as a universal reference frame. It allows us to measure our motion not just against other stars, but against space itself. These sky maps from the COBE satellite reveal a temperature dipole. The radiation appears slightly warmer in the direction we are headed, marked in red, and cooler in the direction we are leaving behind. It is a cosmic Doppler effect that confirms we are locked into a very specific trajectory. According to Hubble's law, the expansion of the universe should push distant galaxies away from us at a speed proportional to their distance. But our velocity is 600 kilometers per second faster than that expansion predicts. Something with enough mass to override the expansion of the universe is dragging the Milky Way across the void. When astronomers look toward the coordinates of our drift to find the source of that gravity, they see a void. The destination for our entire local neighborhood appears to be completely empty. This gap in our maps is the Zone of Avoidance. It covers about 20% of the night sky, a region where optical telescopes are essentially blind to the distant universe. The obstacle is the Milky Way itself. We live inside a flat disk of stars, and when we look toward our destination, we are peering through the densest part of that disk. A thick wall of debris, gas, and dust completely blocks the visible light from whatever lies beyond. We are falling head first into a cosmic blind spot, drawn toward a massive gravitational center that we cannot see with our eyes. In 1986, a team of 7 astronomers, later nicknamed the Seven Samurai, began an all-sky survey to resolve this mystery. They compiled a database of 400 elliptical galaxies to map how gravity was behaving in our local volume. They looked for peculiar velocities. This is the residual motion of a galaxy after you subtract the global expansion of the universe. If a galaxy is sliding sideways or faster than expected, it means a local mass is pulling on it. The team discovered that galaxies across an entire hemisphere of the sky are streaming toward a common point. The math suggested a mass concentration equivalent to tens of thousands of Milky Ways. Team member Alan Dressler named this regional gravitational anomaly the Great Attractor. While the team could calculate the weight of the attractor by the way it moved other galaxies, the dust of the Milky Way still hid the object itself. To find it, they had to look past visible light. Over the last 30 years, astronomers have bypassed the dust by observing the universe at different wavelengths. They traded traditional glass lenses for sensors that can detect light our eyes cannot. Near-infrared imaging was the first to pierce the veil, tracking galaxy flows that converge about 250 million light-years away in the direction of the Centaurus and Hydra constellations. High-energy X-rays pass through galactic dust unimpeded. Projects like CISA used these X-rays to find the hot, glowing gas of massive galaxy clusters hidden deep within the Zone of Avoidance. Radio astronomy provided the clearest view. Neutral hydrogen gas emits a specific radio signal that travels through the Milky Way's dust lanes without being scattered. Using large-scale radio surveys from facilities like the Parkes Telescope in Australia, astronomers identified nearly 900 galaxies behind the dust. They unveiled enormous structures, including a massive wall of galaxies and the distant Vela supercluster. Peeling back these layers of the electromagnetic spectrum finally unmasked the Great Attractor's hiding place, revealing it wasn't a single object at all. Early models of the Great Attractor suggested a singular, hyper-dense mass. Modern simulations based on thousands of galactic velocities show a more complex, fluid structure. The Great Attractor is a basin of attraction. It is a regional gravitational valley within a much larger supercluster called Laniakea. Galaxies in our neighborhood flow toward it like water following the contours of a watershed. There is no single center to hit. The Great Attractor is simply the focal point where these galactic rivers are mathematically destined to meet based on the current velocity field. The phantom dragging our galaxy is actually the shape of space itself, a massive invisible dip in the geography of our local universe. Despite our speed, the Milky Way will never reach the center of this basin. Dark energy is expanding the universe at an accelerating rate. It is creating new space between us and our destination, faster than we can fall toward it. Billions of years from now, this expansion will overcome local gravity. The Laniakea supercluster will be physically torn apart, and the rivers of galaxies will be diverted. We are falling toward a destination that is receding faster than we can travel. We are doomed to spend eternity in motion, chasing a cosmic phantom we will never reach.